Welcome to Train Signal. I'm Ross Bagurtis. In this video, we're going to be talking about VLAN trunks. Now, there are 3 videos in this series about VLANs. The first one we talked about was Introduction to VLANs and VLANs in general, and we just set up basic VLANs. This one, I want to show you how we can make VLANs useful using VLAN trunks. So what a VLAN trunk does, so VLAN trunk is pretty simple. So if you remember, a VLAN is a broadcast domain. And what a VLAN trunk does is it allows us to transfer these broadcast domains, multiple broadcast domains, over one single link in between 2 switches or 2 networked devices. So what we do is we hook up a cable, a wire, or Cat5 cable between our 2 switches. Usually we do this on our fastest ports on the switch. And then what we can do is we can configure that link in between those 2 switches as something called a trunk port or a trunk link. We configure the ports on each end to be trunk ports, and then the link in the middle we call the trunk link or the trunk. And what we do is we configure it to carry multiple VLANs of traffic. And the nice part here is that this trunk link still maintains the individual and separate broadcast domains for VLAN 10, VLAN 20, our web servers, and VLAN 30, the accounting servers. So we have 3 separate VLANs, 3 separate broadcast domains. None of the devices in VLAN 10 right now can talk to the devices in VLAN 20. None of the devices in VLAN 20 can talk to 10 or 30. And none of the devices in 30 can talk to 20 or 10. All right, so the devices within VLAN 10 can communicate with each other, the devices within VLAN 20 can communicate, and the devices within VLAN 30 can communicate. Remember, we need to add a router to this in order to establish communication in between our different VLANs. Since we're not quite at that stage yet, we have another video called Inter-VLAN Routing, and we'll talk about how we can build a trunk link in between our switches and our routers to do really nice routing. It's oftentimes called router on a stick. It's also called inter-VLAN routing. At any rate, for this one, what we want to do though is just hook up these 2 switches together. Now the way this works from a functional standpoint is that when a device on VLAN 10, let's say this bottom device here wants to send a message to this device up here on the top that's connected to our top switch, when we send that message is going to go to the switch. When it hits that trunk port of the switch, the trunk port will add information to the frame header. That information is called the VLAN Tag. All right, so it puts the VLAN Tag on there, which identifies which particular VLAN that frame belongs on. It can then send the frame over our trunk link. When it reaches the other side, it will actually remove the tag header and then place that frame on the proper VLAN so that it stays on VLAN 10. The same thing will happen with VLAN 20 with their web server. So if our web server and accounting server are sending messages as well, when our web server traffic hits that trunk port, it's going to add the VLAN 20 tag on it. It's going to send it across the link. Then our next frame comes across for VLAN 30. We add that frame header while the other frame is being processed and sent up to web server 1. This one can be sent up to the accounting server now. So our traffic now stays within our VLANs even though we have multiple switches. And we can cascade these switches pretty much as long as we want. So we can have multiple switches connected together through different geographical locations using these VLAN trunks to keep the traffic all within a same broadcast domain regardless of where the device is physically. All right, so we can put these switches all over our network and use the VLAN trunks to connect all the switches together so that all of our devices across multiple switches still belong to one broadcast domain.